Hello everyone. So in this video we are going to discuss a different technique that is known as rail fence technique. So the technique, whatever we have seen so far, so all in those techniques what we were doing, we were involving the substitution of ciphertext symbol for a plain text symbol. So this is a very different mapping technique. Rail fence is a very different mapping technique. It is achieved by performing some sort of permutation on the plain text letter only. So that's why this is also known as, this is referred as transposition cipher, because in it we are just encrypting it using some kind of permutation on plain text. So that's why we say it is a transposition cipher, and the technique, the simplest technique is known as rail fence cipher. So how this rail fence cipher work? For example, the plain text is meet me after the party. The plain text is meet me after the party. Now how we are going to write a cipher text, or how we are going to encrypt it? So we will write it in a depth of 2, like the road fencing. Like it means M E, then we will start from here E T M E A F T E R T H E P A R T and Y. And when we are going to write the encrypted message, or when we are going to write the cipher text, what we will do? We will simply read it from row. So it means now the ciphertext will be M E M A T R H P R Y E T E F E T E A T. So this is going to be our ciphertext. So we just put a permutation only on the plain text and we get the ciphertext. This is a sort of thing which would be very trivial to cryptanalysis point of view. So I mean like it is very easy to decrypt this cipher. So in more complex scheme, we write a message in form of rectangle, and we write it row by row and read the message of column by column. And what we do, we permute those columns also. So the thing is, we are going to write it row by row in a rectangle form. So rectangle means it should be n by n matrix or m by n matrix, and then we are going to read it column by column, and we put some kind of permutation on column. So for example, let me do it here. For example, a plain text is, the plain text is attack postpone until to AM. The attack postpone until 2 AM. So let's say this is the plain text, and we are going to write it in the form, in a rectangular form. So but how we are going to create a rectangle? So let's say the key for this kind of encryption is 4-3. It is a random key generation is always a random algorithm. 4-3-1-2-5-6-7. So the how many letters are in the key? There are 7 letters, 1 2 3 4 5 6 7 letters in the key. So our rectangle will have 7 columns. So now we will write it in 7 columns. A T T A C K P, O S T P O N E D. This is O. U N T I L T W O A M. And whatever is left, we will fill it with, let's say, X, Y and Z. So in leftover we filled it like this, X, Y, Z, and maybe some, if more are left, then we will again fill it with X, Y. So we can fill it like this. Now, how to write the ciphertext? How to find the ciphertext? So wherever you have 1, this is 1. So this column should be written first, T T N A. Now this is the second column, so I will write this second column next, A P T M. Then third column, which is T S U O. Then fourth column, which is A O D W. Then fifth, which is C O I X. Then sixth, which is K N, this is N, which is K N L Y, and then the last one P E T Z. So this is how we are going to encrypt it. So this is more trivial than the first one. The previous one was very simple, like rail fence was very simple, and this is again a trivial one. But this is a pure transition cipher is easily recognized because it has the same letter frequency as in the original text. I mean, like how many words you have in plain text, almost the letter frequency is same. For the type of column transposition, I just show you the type of column transposition. Cryptanalysis is fairly easy and straightforward. It involves laying out the ciphertext in a matrix, play around with column position. Whenever we play around with column position, we can simply get the plain text. So to make it more critical, from the attacker point of view, to make it more critical, what we can do, we can add some more transpositions. We can add some more transpositions. So like for example, one more time we can do the similar transposition. So for example, second time we will use this ciphertext as plain text. So let me write it here. The again key is 4 3 1 2 5 6 7, and I am going to write this T T N A P T M, then T S U O A O D W C O I X K N L Y P E T Z. So this is, you can say this is initial ciphertext, and now we will get the final ciphertext. So we do this kind of permutation 2 times. So this is final ciphertext. Now we will read it column wise, starting from the 1. So it will be N S C Y A U O P. Now we will read third column T T W L. Then we'll go to the fourth column T M D N. Then the fifth one A O I E. Then the sixth one P A X T, and then the last one T O K Z. So this is how we will get the final ciphertext. This is how we are going to get the final ciphertext. So we add more permutations just to make our ciphertext more secure. So just to analyze this situation, that how it is more secure, let me write the two ciphertext. So for example, the first one was this one. The initial was this one. TTNAA, TTNAA, PTM, PTM, TS, U, O, A, O, D, W, C, O, I, X, K, N, L, Y, P, E, T, Z. Now let's say there are 28 letters because we have 7 columns and 4 rows, so there are in total 28 letters. So let me write positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, then 21, 22, 23, 24, 25, 26, 27, 28. So let me write the letters also. Me, attack, it was attack, postponed, PONED, until, UNTIL, 2 AM and XYZ. And when we get this initial ciphertext, so you see this T is at 3 position, so we get 3. Then again T which goes at 10. How it goes at 10? Let's go to the matrix. So 1, 2, 3, this one is third position, 4, 5, 6, 7, 8, 9, 10. So this one is 10 because we write it like this. So this is 3, this is 10, then 11, 12, 13, 14, 15, 16, 17. So this is 17. Then again A is at 24 position because it is here. So in ciphertext it is here. So we are just writing at which position it goes. So let me write it here. So I show you how we write. So this is like 3, 10. It will be like 3, 10, 17, 24, 0, 4, 11, 18, 25, 2, 9, 16, 23. Then 1, 8, 15, 22, 5, 12, 19, 26, 6, 13, 20, 7, 14, 21, 28. So if you see this, there is a pattern. Every time we are going to add 7. 3 plus 10 is 7, 10. 10 plus 7, 17. 17 plus 7, 24. Then 24 plus 7, because we have only 28, so it goes to 4. Then 11, then 18, 25. So it will be like that. So you can easily see that if we go the initial, we do only one time permutation, we get a pattern. But let's check about this one, final one. So let me write it again here. So it is, the final one is NSCY AUOP TT WLT PPWLT MDNAO IE PAXTTOKZ. So when we like decrypt it like like earlier, so we will get, for example, so we will get these numbers: 17, 9, 5, 27, 24, 16, 12, 7, 10, 2, 22, 3, 20, 3, 25, then 15, 13, 4, 23, 19, 14, 11, 1, 26, 21, 18, 8, 6 and 28. So you easily see that there is much less structured pattern. So it means cryptanalysis is difficult. So it's better to put more permutation, more column type permutation. So this is again kind of transposition cipher in which we can permute only on the plain text. We are not using any, we are not changing the letters of plain text, we are just permuting it. Okay, so in next video we will check another type of ciphers. Thank you.